All right, it is 4:25, so we're going to go ahead and get started. Welcome, everyone. My name is Robert Bailey. I work at Google, and I'll be your track host for this session. And today I have the pleasure of introducing Yuan Chen, who's going to talk to us about how we can use Toolkit to do some performance testing of large-scale Kubernetes clusters without actually having to spin up large-scale Kubernetes clusters. So please, everyone, give a warm welcome to Yuan Chen, and we'll get started.
Thanks, Rob. Can you hear me? Okay. Good afternoon, and welcome to this session. I know this last technical session, so I really appreciate your attendance. So I'm Yuan Chen from JD.com. This is a joint work with my colleague Qi Chao and Haifeng and Guang and Jian Gang. So let me first allow me, and probably not many people know the JD.com, and so I just would like to spend a few seconds to talk about it. So JD is the largest online and offline retailer and internet company actually by revenue. You probably heard Alibaba and other company, but by revenue we're the largest one. In addition to that, JD also provide the largest the logistic and the fulfilled network and nationwide in China. And we build a very good and strategic partnership with Google and Tencent and Walmart. So I'm part of this JD retail and infrastructure team. So you can imagine that behind this business, and we are a technology and driven company. So we are one of the earliest adopter of the Kubernetes and container technology. And right after Google announced open source Kubernetes in later 2015, and we start looking at Kubernetes and gradually adopted and transitioned our business and application to the Kubernetes based system. So we joined the CNCF and as a platinum member, and also won the end user award last year at KubeCon Shanghai. And I want to give you one number, and this infrastructure, our containerized infrastructure is the foundation, for example, support our just the past, we call it a single day and major and the sale event. The single day is November 11, right, 4 and 1. And so you can see this and the sales number, around, this the 30 billion US dollars. So this is huge. Some QPS is about like the 150 million queries per second. And yesterday, if you attended keynote talk, the Planet Skill and the CTO Shugu mentioned our collaboration and use the VTest and build some elastic database, and that's the number we have. So, but this is basically a high-level architecture and of the entire this software or technology stack. So I'd like to the top down and give you ideas. So like I mentioned earlier, JD, we have some online and of course online shopping services, and we also have this logistic thing, and also have a separate unit and just looking at all this and applying advanced AI and machine learning technology to solve the problem. We have the AI workload, and overseas, and we have the site and in Thailand and Indonesia. Also, we have some the offline the retail store. We call it the 7 Fresh, and for this 24-hour right, provide this and the fresh and the grocery and the service. So of course, our workload is very diversity, and we have this in the online microservices, and we also running a lot for the big data analytics, machine learning workload, and the AI workload because of this and logistic and networking, and as well as our offline and retail store, and we also have some IoT kind of edge computing workload. So, but at the core, and we internally we build some customized and optimized and system, some storage and in data, in memory and cache system, and some MyCircle or the structure and the transactional database and the object store, messenger system, other thing. But the core is our this and the JD and highly customized and optimized and container and Kubernetes and platform, and we call it JD Data Center OS. Is basically is a customized version of the Kubernetes, and so it support all this and kind of the different and the workloads and all of the JD's business. so you can imagine during our journey, right? And we started using the very early version Kubernetes, and we start from a few hundreds of the nodes per cluster to today, and our one of the largest cluster, Kubernetes cluster, we have more than 10,000 physical nodes and CNCF and recognize, and we are running one of the largest Kubernetes cluster in production in the world. So this is hard, and when we try to optimize something, we add a new feature, we develop a new scheduling algorithm, how to evaluate, right, validate the effectiveness, and so this is always a very challenging problem. And so, but the good thing is, right, and in the scientific study research and the simulation is always a very useful and a tool. So here we look at this is, can we leverage and take advantage and by using some kind of the simulation technical to help us to evaluate, validate, and our software and the new features and the scalability performance. So if we look at the systems and the cluster management, right, from the Kubernetes and or Mesos or the Hadoop Yarn, and we started looking around, and we did some study, and we found out definitely there are numerous of the tool software available and do some kind of the simulation or emulation. But unfortunately, yeah, if we really want to and do very realistic, complex simulation scenario, for example, you can replay the real trace. You also can create some what-if analysis kind of thing, and you not only do this in the performance and evaluation or the metrics, you also want to look at for example, your scheduling and the placement and the quality, and finally, can it provide some good visualization or dashboard to help you and understand, right, the behavior and behind the screen, and none of them actually can meet all this requirement. So as part of that, and we identify and in order to meet the goal, and we really can help us to validate and the evaluation and also the validation, all these tools, in particular the improvement and the optimization of the scheduling algorithm. And we want to have a simulation tool which enable us can do and simulate and evaluate at a very large scale. Also, and of course, we want it can mimic the real behavior and as much as possible. And finally, and we want it can very easy to set up all this and support and some good, provide some very good and this visualization or dashboard. So far, and I hope you got some background, understand or know and our company a little bit, and why we are here and why we started working on this. So next, I'm given more detail about this simulation, the architecture design, and some the implementation, the details. And I will also present a few case studies and how we use this and simulation tools help us and optimize, improve our Kubernetes and the larger scale and this and the massive and scale and Kubernetes cluster and the efficiency and reduce the cost. And if I have time, and I'd like to give a very brief demo, and I will be here after the talk, and be happy to answer any questions you could have. So okay, we call it a JoySim, and it's a Kubernetes and a simulator to simulate the Kubernetes and particularly is the scheduler. Of course, we can also evaluate this and the Kubernetes master and APIServer performance. So the idea is quite very simple. So we run the Kubernetes master and the real master, right? This including and the APIServer and all these and controllers and etcd, and this is the real thing. But the real and the bottleneck is, of course, we cannot afford to run the real and physical nodes, so we just emulate, simulate, and Kubernetes, and we run it inside the containers. So each container we can run, depending on the configuration, we can run up to, more than 100 of the simulate more than 100 of the Kubernetes nodes or the Kubernetes, and later there are more details. So also we provide some nice interface, and we can import or populate this and simulated Kubernetes cluster, and either using the realistic configuration from real and the Kubernetes clusters, or you can define and create some kind of the scenario you really want to simulate, define the configuration file. The event side, similarly, and we provide two kind of the modes. The first one is just the reply, collect the events from your real and clusters and replay the events and the traces. The second one is you can create some the synthetic and the workloads or the traces, and then play this and the traces and do some kind of what-if analysis. We support both this and the online and offline kind of the simulation. In my case study, I will show one example is do the offline and schedule and performance evaluation. Another one is basically we use this simulator and do conduct this online performance and or the decision and making and making Finally, is the simulation platform itself is managed and deployed by the Kubernetes itself. So it will be easy to scale down, scale up, and operate. So this is the architecture, and so as you can see there is, so we have our real and cluster running. So there are two things we collect from our real cluster. So the first is all these and interesting events. So we collect it and save in a database, and in our case is the InfluxDB. The second one is all this and the configuration and the related information, and this will be used to populate and created our Kubernetes and simulated Kubernetes configuration. So the one component interesting here is this and the simulated nodes, and we use this and the workloads, and so each workloads and basically is simulated and Kubernetes and a node, but multiple modules running inside a container. Another thing is because you collect the data, this time step and the other thing and need to be somehow calibrated. And so we have some tools that make sure and all this information in a consistent view, because you could collect it from all different clusters in different time zone and other thing, and we have to do that. So finally, we have very nice and the dashboard and visualize and collect all this information, not about the performance. We have some heat map and visualization about the quality, and later, and I will show you some more details about that. So let me just go through each of the steps and in a little bit and more details. And so firstly about the events. So the events, and like I mentioned earlier, and firstly we can collect and very detailed events from each of the system. Now there are tons of tools and could help you and do that. And just I think 2 o'clock in the session, and I attended the session talk about the events are not interesting use cases actually. This and could be a use cases as well. Collect the events and do the simulation. So far our implementation, and we collect the data is a plugin and the agent, this and the telegraph. And then we store all this and the data in the InfluxDB. Of course, this doesn't mean it's the best and implementation, and that's just our choice at that time. That's the best one available for us. So probably it's not in the very, and it's readable, and but the slides is available and online. You can look at more details, and all this and the event or configuration and the information, and we collect there. The second one is, and we also provide like a synthetic and the trace generate. You can define the different kind of a scenario, right? You can define the cluster size or the scale, and you can define each node and what's the capacity, the resource, and the CPU core and memory and disk space and etc. And then for the event generation, you also can define, we provide and plugin, and so far the default and plugin and can provide you generate, for example, like this and the arrival rate. You want this port, for example, creation event, right? Should be the arrival rate? What should be the distribution and the inter-arrival rate, right? And that's just to mimic the real cases. So that's very helpful if you really want to do some what-if analysis. If there are a port and coming and require like the 1,000 and the containers, so what the scheduler and the behavior will look like if there are 5 kind of these jobs and coming and what the cases could be. That's very useful for us for the single day and the major sale, right? We want to do this stress testing. Sometimes we create some kind of a scenario. We want to evaluate the performance scalability and identify any resource bottleneck in our system. So the node simulation and the concept here is also very simple. And so we basically use Kubernetes and start a bunch of, you can specify and a bunch of the pods or containers. So for each container, then depending on the resource capacity, and you could start and simulate from 10 to more than 100 of the Kubernetes and nodes. So then this and the Kubernetes and basically just mimic the real behavior and of the Kubernetes, right? It will interact with the API server. And interesting, it also watch all these events. It also report and like the resource usage other things. So from the API server or the master controller perspective, it's just like a real and the Kubernetes, of course. And this and the simulated and the fake Kubernetes and does not and the real and allocate or start any real containers. So like one very in the typical configuration in our system, like if you use like 8 core or the 16 gigabytes and the memory and kind of the setup, at least we can run more than 100 of the simulate more than 100 of the Kubernetes, we call it or workloads. So here is a little bit and more detail and implementation kind of the component level of the architecture of our system. And the bottom line, at the bottom, and we could actually create a multiple and the simulated and the clusters. So each one, like I said, it's running a real Kubernetes system, and because the mock server and is a pod and in the real system. Then each one have a multiple one, or for the high availability, it can have one or multiple and the API server. Then our dashboard and aggregate all this information and to visualize and display all this information. User can interact with it, and it didn't show here, and we have this and also the user interact with it. We provide some command line tool, and also you can import and populate the configuration traces. Also you can export and all this and the results or simulation results as well as your configurations. So the visualization later, and when I show the demo, and you probably can get a better idea. And here probably not very readable, but anyway, so we have the all kinds of the metrics, and from the performance, like the API server's performance and the scheduling performance, and also scheduling and the placement and the quality and all kinds of this, and the current status of the cluster. Also we report and have a customized and the range definition, the query interface, and you can search and look at all this. Maybe I just scale to one of the, for example here, and for the scheduler, and we couldn't break down into for each stage, and when you do this and for the filtering, right, at the first stage you choose the feasible nodes, and we have this and the heat map and about this and the latency distribution about your this and the predictor and the performance. And also the second stage is about the latency. You do the scheduler do this and the ranking or scoring and each of the nodes, right? You want to choose the best nodes, and we have very detailed and the distribution information about that. Or the overall and the performance or latency about your scheduler, and also I think this one is, the binding time. If you are familiar with the Kubernetes, the scheduler, you probably know, and so basically there are 2 stages, right? One is make the decision, the second is the binding, is basically put into the API server and add CD and the database. So we provide all this information, and you can easily to analyze and understand the performance of the scheduler, also the QPS, and all kinds of this, and the statistical data, and for help you understand that. So, okay, so basically, in a quick summary, and so this tool, and we enable the user and can collect and replay and the real traces and the events from real and clusters, also and customize, define and the traces or the configuration and of the cluster. Then we can run the replay these traces and collect the detailed information about the API server's performance, and as well as some scheduler and very detailed metrics help us understand the behavior or the performance and behind the screen. So now let's look at a few and case study. So the first one, as if you look at what's the scaling the limit or the bottleneck. If you want to run, you probably ask me, will you run a Kubernetes and over 10,000 nodes, right? What's the main and the bottleneck or the key? That's the API server or all this and related and masters or etcd. And so firstly, this tool help us understand that because we run this in the real and etcd there, right? And even the Kubernetes itself and does not start or launch a container, but all this behavior interact with this and master node is real. So this help us understand. So for this experiment, for example, we started and 18,000 containers and act as the mock servers. So then each these mock servers and we use it to simulate and 100 of the about 100 of the real pods in our simulated environment. So this enables us and basically simulate over 10,000 of physical nodes and about 200,000 of the containers. So then we also set up like the 6 and the API server for some load balancing, also the high availability and stuff. So at the beginning, now of course, the etcd has done a lot of the work, and also Alibaba and other, I think players and try to optimize the performance because etcd and regionally we realize this and 5 gigabytes or 10 gigabytes and the storage limited will be the problem for larger scale deployment, and some memory allocation algorithm, other thing could become a bottleneck. So one improvement optimization we did, and when we started the scale out our Kubernetes clusters, we just use multiple and etcd clusters and to store different resource type and objects. So for example, for very popular like this pod creation and pod resources objects, we use a separate and etcd and cluster store it, other we use a separate. We also apply some compression and put a cache layer and Redis and in front of the etcd. But doing all this, and we have to evaluate and validate and whether or not it works. So we just use this tool and validate. Then we find out, we replace some real traces, and we find out everything is fine. The API server, the etcd performance, and we didn't notice and any significant or some and very serious and problem. So let's give us the confidence. And also at our very end, in our very early work, and we look at the scheduler and we did some optimization and adjust and optimize the scoring and the function, and we improve our the scheduled QPS from the 2 and to the 40, and we also use this and the simulation to help us to evaluate it. So the second and the study is what our team and have just done recently, and so I'd like to give you some context. So now within JD, we like I mentioned earlier, and we not only run the online services and the traditional and the stately services, and now we move because improved utilization, co-scheduling, co-locate to the online services and like the batch jobs and the big data and workloads. So in the community, and there are a lot of ongoing work and very active, like the Kuberbatch and do this and batch job scheduling and like the Spark. When we run the Spark on Kubernetes, one of the problems we found out is the performance scalability. So our business, sometimes they launch this in the Spark jobs, and it requires like this and 2,000 or 7,000 of the small containers and run a batch. Probably it will last a few minutes. But the existing and the Kubernetes and the scheduling, and if you are familiar with it, it conducted the schedule and scheduling and pod by pod. So we find out the throughput and the latency and is not acceptable if we want to support this and the high throughput and the kind of workload compared to the traditional Yuan. So we did some kind of the optimization for it. If you're interested, we can talk. And so in June, Shanghai KubeCon, I gave a talk. And if you go back there, and we have some information there. Basic idea is we just do this and treat this quality for the performance. So we don't need to choose the best one, right? We can, because this and the requirement, 1,000 or 2,000 container, their requirement are very similar. So we could just do a group, we call it group scheduling and group binding, just do it once so we can improve the significantly. So during our this and optimization and development and the phase, so we went through quite a few phases. So how do we evaluate the effectiveness of our algorithm? So we use our these simulation tools. So from our regionally, and we create and simulate and cluster and just use a few or tens of the containers. So simulate like thousands of those and running like close to 10,000 of the pods, and each of the scheduling job then require 500 of the pods. So here they show the number as we keep improving our algorithm, how we significantly improve the schedule performance. So once we reach this stage, and we also did other functionality, scalability, stability, and evaluation use those tools. Finally now already deploy this and optimize scheduling into our system. So I'm talking and working with the KubeBatch and Volcano and community and see how we can actually open source all this improved and schedule and to make it available to the community. So last one, I want to also highlight one of the key and feature or interesting scenarios. We not only use it for this offline evaluation and when we have a new algorithm, a new schedule or other thing, and so we also incorporate into our online decision, and in particularly for and like the JD I mentioned, we have very large scale for all this and online services and within Google, and also want to differentiate different kind of workloads. So for the very long running and performance critical one, we can afford some kind of this and long running and the decision to just find the best and the placement and make sure that everything is working fine. So, but it's very hard to come up with a closed form kind of the magic algorithm and find this bin packing other thing. So we basically, when we do this and decision, and we use this and simulate and to evaluate our decision, then only we get some confidence this work fine, and then we'll actually deploy it or execute and this and decision or take the actions. So for example, here is one, and we use it to predict some of the memory usage, and then based on that, we consolidate or rescheduling the pods and the containers. So the results here is we only, without consolidating and the co-scheduling batch and the online service, just run the online services. This is very latency and intensive or sensitive one. And we can improve this and the memory usage average one to the 61% without basically we almost eliminate all this out of the memory and errors. And to my best knowledge and compared to the literature and reports and a lot of things, and this is a very good and result. And why we can do that? We have some advanced algorithm behind this is because we use this simulation and which enable us and to evaluate very extensively and give us some confidence. For example, sometimes we find that workload is very hard to predict. We basically use some very conservative and approaches. Once we get more historical data, and we are very confident about our predictions, and we will apply and this, and for example, the threshold and much more aggressively. So to summarize, and so this, we introduce and describe a tool and which enable us to simulate and the Kubernetes and the systems and with at a very large scale. And this tool, and we have used it and extensively and at JD, and to develop the new tools, evaluate the scalability, and in particularly and help us to develop our advanced and scheduling and policies and scheduling algorithms. So now and we are working and very closely with the SIG scheduling and working group and try to make it and available to the community, open source release it. So since I'm running out of time, I really want to leave and 5 minutes for the Q&A, and I have a demo if you're interested, and I can show you and after talk. Okay, again, thank you very much. Yeah, so this is my contact information, and I'd like to take maybe a couple of questions. Can you turn the mic?
How do you keep the simulator in line with the behavior of the version of Kubernetes?
So far, and that's good one, because our real and the API server and the master, right? We run the real one, so we always that's easy one. We deploy the latest one. So the only thing is this and the Kubernetes and our simulated one. But to our based on our experience and the major and upgrade or new release and the Kubernetes, because for us and what we are most interested in events is when you create a new one, you delete a new events, and all these new and the features, for example, and the upgrade and seems not and change much and for our this and the mock server, but did some changes and require us and adjust our this mock node and API, the interaction with the API server. So the short answer is yes, we have to keep an eye on the upgrade of the new version. So far we are not always, we still have not supported the latest one. So far we supported 1.14 and so.
Yes, I have a question here. I'm trying to understand how accurate is this model to understand how the scheduler behaves in Kubernetes. The reason that I'm trying to understand this is because if you have a bare metal server that has, let's say, 100 kubelet instances, as long as one single kubelet instance is running an application that is consuming 80% of the CPU, the other kubelet instances obviously are going to see 80% of the CPU. So your scheduler is going to go crazy saying, you know what, I have a bunch of kubelet instances here that I seen, they are seeing 80% of CPU because the process is virtualized. So how are you going to deal with that? How are you going to make sure that your scheduler doesn't react in those scenarios?
That's a good question. So that's the one of the, I think the limitation or limits I should mentioned. So as you can, you ask the question. So our Kubernetes, because the Kubernetes, the simulated Kubernetes, and it does not launch any container, and it does not run any real workload. So we reported basically just your request, right, and the capacity. So, but most of the current, at least the existing schedule and make the decision, mostly is based on that. But the new features like this and HPA, right, and VPA, and also based on the real usage of this and the physical node or this and the Kubernetes node, so far, we cannot handle that yet. But we think about that, and we think in one way, and we could also introduce and some kind of this actual utilization into our the simulated environment, and so then we can buy it and also can create it some kind of simulated environment, show some kind of this not only just your request and capacity, is the actual resource utilization or usage of your system. So, but the hard thing is then your scheduler make a decision and or how it impact the usage. So that's a challenging thing. You could use some kind of a model and based on the historical data you created, for example, I know your actually CPU cycles usage, and now I know you make this decision. I could do some calculation, but how accurate and this could be, and still open question. So far, and for this, if you need some real measurements which based on the real workload behavior, so far this tool and still cannot do that. Yeah.
We have time for one more quick question. If you guys have questions afterwards, feel free to come up though.
Hi, in scheduler optimization perspective, currently I understand very long time scenario takes very long time, the equal time, this simulator.
Yeah.
Do you support running with simulated clock or something for more faster simulation?
Yeah, so that's why, and it's probably somehow it's an emulation or something. Yeah, so far we just, because this and the traces and the behavior, and if we replay the real traces, yes, so far we replay it at the same pace and as the original one. But that's a very good point, and for some scenario, in particular for this and what if analysis, I think it really depending on your use cases and the cases. Yeah, for some cases it really matters, and how fast, and like I said, the inter-arrival and the workloads are coming. But there might be some cases, and if you want to evaluate, for example, some stability or other thing, and if we can support and faster paces, that's going to be, and I think, very nice features. Yeah.
All right, well, thank you everyone for coming. Let's give one more round of applause for Yuan Chen.
Okay, thank you very much.
And one last thing as you're leaving, please don't forget to rate the talk on Sched. It's really helpful for the conference organizers to make sure we're getting the right talks for you guys. Thanks.